Hello, welcome to my channel. This is S.D.V Academy. I am Asra Nazdin. Okay, today we will learn the topic about legendary equation, method of variation of parameters, bending of beam, and application of electric circuits. These four concepts today we will learn. Now, let us start. Equation reducible to linear differential equation with constant coefficient. Okay, Cauchy's homogeneous linear equation. Okay, this is the first type. An equation is of the form of x power n d power n into y by dx power n plus a1 x power n minus 1 d power n minus 1 into y by dx power n minus 1 plus a2 x power n minus 2. Here you have both the constant term and the x term also. Okay, where here a1, a2, a3, a4 and so on, n are the constant terms, and capital X is the function of x only and is called the Cauchy's homogeneous linear equation of order n. Okay, you have nth order here. Equation 1 can be reduced to the linear equation with the constant coefficient by changing the independent variable. This independent variable we have to change, x value we have to change. So in the place of x, put a e power z, not z is equals to log x, where x is greater than 0. dz by dx is equals to 1 by x. Okay, the value of dz by dx becomes the value 1 by x. Now, dy by dx is equals to dy by dz, dz by dx. Okay. Now, 1 by x dy by dz gives the value x into dy by dx is equals to dy by dz. Okay, denoting the value of d. d by dz is equals to capital D. X into dy by dx is equals to dy by dz. Okay, in the place of x square you can write d square y by dx square d into d minus 1 into y, and in the place of x cube d cube y by dx cube is equals to d into d minus 1 d minus 2 into y. Substituting these all values in equation 1, we can solve the equation. Okay, now I'll give you one example so that you can understand the equation here. Okay, solve x square d square y by dx square minus x into dy by dx plus y is equals to 2 log x. Okay, now put x is equals to e power z, so the value of z becomes z is equals to log x, where x is greater than 0, and denoting capital D is equals to d by dz. So in the place of x into dy by dx gives the value d into y, x square d square y by dx square is equals to d into d minus 1 into y. Okay, substituting these two values in this equation gives the value d into d minus 1 minus d plus 1 into y is equals to 2z, sorry, log x 2z. Okay, now here, what is the value it becomes when you solve this? D square minus 2d plus 1 into y is equals to 2z. Finding the auxiliary equation gives the value m square minus 2m plus 1 is equals to 0, where the value of m is equals to 1 comma 1. Okay, CF value is c1 plus c2 z e power z. Okay, finding the pi value 1 by d minus 1 whole square into 2z, that is equals to, take this to the numerator, gives the value d minus 1 whole power minus 2 into z. So taking 2 common here, d minus 1, this is the binomial expansion. By using binomial expansion, what you can find 2 into 1 plus 2d plus and so on into z. Okay, take only the value of d, in only the value of d. When you take d square, when you double differentiate, this value becomes 0, so no need to take the larger values. Okay, 2 into z plus 2d into z, multiplying these 2 and this z to this value gives the value 2z plus 4. The general solution of the equation 2 is c1 plus c2z e power z plus 2z plus 4. In the place of z, put a log x. So what the value becomes? c1 plus c2 log x into x. X means e power log x. So here e and log gets cancelled out, x plus 2 log x plus 4. This is the required answer we have. Legendary equation. An equation of the form a plus bx whole power n d power n into y by dx power n plus a1 a plus bx whole power n minus 1 d power n minus 1 into y by dx power n minus 1 plus a2 a n, here you have a n minus 1. Okay, a plus bx whole power n minus 1 n minus 2 d power n minus 2 into y by dx power n minus 2 plus a n and so on. This equation is in this form. So in the place of a plus bx, substitute the value e power z. So what the value of becomes z is equals to log a plus bx. So a plus bx value is greater than 0. Denote d by dz is equals to capital D. Dz by dx gives the value b by a plus bx. Okay. Now dy by dx value becomes dy by dz into dz by dx. Okay. b by a plus b into dy by dz. Okay. This value becomes a plus bx into dy by dx is equals to b into b capital D into y. Okay. Now similarly, when you take the other values, higher degree values, a plus bx whole square d square y by dx square gives the value b square into d square y minus d. That gives the value b square into d minus 1 into y. A plus bx whole cube gives the value d cube y by dx cube, that equals to b cube d into d minus 1 d minus 2 into y. Substituting these values in equation 1, we can solve the equation. Okay, we can solve the given equation by substituting these values. Okay, now let us continue with another problem here. This is the example problem of a legendary equation. This equation is 1 plus x whole square d square y by dx square minus 1 plus x dy by dx plus y is equals to 4 cos log 1 plus x. Okay. Now, in the place of a, what you have? 1 here. In the place of b also, you have 1. Given equation is in this form. Okay. Now, put 1 plus x is equals to e power z. So, in the place of z, what becomes? Log 1 plus x, and d by dz is equals to d. Okay. 1 plus x dy by dx is equals to dy 1 plus x whole square d square y by dx square gives the value d into d minus 1 into y. Okay, substitute this value in equation 1. What you will get? D into d minus 1 plus d plus 1 into y is equals to 4 cos z. So d square plus 1 into y is equals to 4 cos z. So auxiliary equation becomes m square plus 1 is equals to 0. So m is equals to plus or minus I. CF value is C1 cos z plus C2 sin z. Okay. Now what is the PI value? 1 by d square plus 1, 4 cos z. So you have the cos z value, so you have to differentiate. When you put minus 1 square plus 1, this value becomes 0, so you have to multiply with x and differentiate this value one time. Okay, in the previous lecture I have said you. So 4z into 2d cos z gives the value 2d. Integrate one time. 1 by d means integration sin z. The general solution is y is equals to c1 cos z plus c2 sin z plus 2z sin z. Okay, in the place of z, put log x gives the value c1 cos log 1 plus x. Sorry, in the place of z, you have to put log 1 plus x, c2 sin log x, 2 log 1 plus x sin 1 plus x. Okay, here you are log 1 plus x sin 1 plus x. Okay, now continue with the next concept. Method of variation of parameter. Okay, this equation is a form of d square y by dx square plus p into dy by dx plus qy is equals to 0. This is in the previous lecture I have said you another method. In this method you have linear equation, Bernoulli's equation, and similar to that. Okay, linear equation is in this method only. You here in that you have 0 here, in here you have x. Okay, now let the complementary function is y is equals to a phi x plus b psi x. For finding the value of a and b, okay, for finding the value of a and b, we have to integrate minus x psi of x by phi of x psi dash of x minus psi of x phi dash of x dx plus c1 to finding the value of a. For finding the value of b, minus x phi x 5x psi dash of x minus psi x phi dash of x into dx plus c2. Okay, here you have this value and this value is same. Just you have to change this value only. Okay, it is not harder. You can remember this by just the same values are there, but you have to change only psi x and phi x. Okay, now this is the example form problem for variation of parameters. Okay, The given equation is in the form of d square plus 1 into y is equals to cosec x. Okay, finding the auxiliary equation gives the value m square plus 1 is equal to 0, where the value of m is I minus I. So what is the value of CF? C1 cos x plus C2 sin x. Okay, let pi value is a phi of x plus b psi of x. Okay, where phi of x is cos x, psi of x is sin x. Phi of x, psi dash of x means you have to differentiate this. Sin x gives the value cos x, psi of x cos sin x, differentiate this value differentiate this value gives the value sin x, minus sin x, minus minus gives the value plus. When you multiply these two values, cos square x sin square x gives the value 1. Okay, what the value you got here? 1. Okay, now minus x, what is the value of x here? Cosecant x, in cosecant x, and what is the value of psi of x? Psi of x is sin x into cosecant x, and the whole value here got 1. Okay, minus sin x cosecant x means sin x into 1 by sin x gives the value 1 here. So minus integration 1 dx gives the value minus x. So this is the value of a. D value minus x, phi of x means cos x into cosecant x gives the value cot x, cos x into 1 by sin x gives the value cot x, gives the value log of sin x. Okay, and this value is 1 here. We have already find the value. Okay, cot x by 1. Okay, log of sin x, this is the value. Substituting the value of a and b gives the value pi value is minus x cos x plus log of sin x sin x. Okay, this is the pi value, minus x cos x plus log of sin x means we have the value here a phi of x plus b psi of x. No, so substituting this phi of x here, psi of x here. Okay, now complete solution is y is equals to c1 cos x plus c2 sin x minus x cos x plus log of sin x into sin x. Okay, now bending of the beam, this is the interesting topic that we have right now. Okay, think there is a bridge or any kind of a thing you have. When you put a load, this bridge bends. Okay, this bends like this. Okay, this bends like this. So in some places the okay, and explain you like this. Okay, consider a uniform beam. This is called the beam. Okay, oh, sorry, this is called the beam. Consider a uniform beam which is made up of a fiber lengthwise. Let beam be deflected under given load. Okay, deflected means it has been bent. Then the fiber in some region elongate and fiber in some region are contracted. In between these two regions, some fiber are neither elongated nor contracted in a certain region. This region is called neutral surface. Okay, this is called the neutral surface. The fiber which was initially elongated along the horizontal axis of the beam now lies in the neutral axis. In the horizontal axis means you have this is the horizontal axis, comes to the neutral axis here. The fiber which was initially elongate the horizontal axis of the beam now lies in the neutral axis in the form of curve called deflection curve. Okay, in the form of deflection curve or elastic curve. Okay, this curve is called the deflection curve or elastic curve. Any line in which any plane section of the beam cuts the neutral surface is called the neutral axis AB of that section. This is called neutral axis. This is called neutral axis. Okay, now by Bernoulli's Euler's law. The bending moment M and AB of all force acting either side of the portion of the beam separated by this cross section is given by M is equals to EI by R, where E is the modulus of elasticity of the beam. I is moment of inertia of the cross section of AB. R is the radius of curvature of the elastic curve at point P x comma y. The formula of the given radius of curvature is R is equals to 1 plus dy by dx whole square whole power 3 by 2 by d square y by dx square. Okay, this is equation 2. For small deflectivity, small deflectivity means for small, okay, 1 by d square y by dx square. Since the slope of the elastic curve is small, higher power of dy by dx can be neglected. Okay, now substituting 3 in 1, we get m is equals to ei d square y by dx square. Shear stress dm by dx differentiate with respect to x, ei d square y by dx square. Intensity of loading d square m by dx square is equals to ei d power 4 y by dx power 4. You have to differentiate it 2 times. Important note here, the bending of momentum can be taken positive if the moment about a section of the left of the section are anti-clockwise direction, otherwise negative if the movement are clockwise. Okay, if the movement is clockwise, and if the movement is anti-clockwise, this is clockwise, this is anti-clockwise direction. If the movement is anti-clockwise direction, you have to take it as positive. If the movement is clockwise direction, you have to take it as negative. Okay, example problem here. A beam AB of span L carries a distribution load of varying intensity as shown in the following figure. Measure x from the end A, establish the equation of deflection curve for the beam, hence calculate the deflection at the center of the beam here. Okay, we have to measure the value of A here. Okay, now here this is the value of W, this is the value of W, AB, RB, RA, and this is the value of L here, and we have to take this is the value of X here. Now this is the value of X here. In between the values are here, there no, so this is the value of X. Now we have to calculate this X value. Solution. Consider a section of distance x from the end A. Okay, system of x from the end A. This is x. Okay, this is the end A. The rate of loading at the section is x by L. This is x by L into W. Taking moment about P, we get RA into L is equals to WL by 2 into L by 3. This is L by 3 and this is W by 2. Okay, RA is equals to WL by 6. Now MX, okay, is equals to RA into X minus X by L into W into X by 2 into X by 3. When you multiply these two, all value gives the value WLX by 6 minus WX square by 6L. EI is equals to D square EI into D square Y by DX square is equals to minus MX minus WLX by 6 plus WX cube by 6L. Okay, now integrating these values, when you integrate these values gives the value EI dy by dx is equals to minus WLX square by 12, this value x square by 2. Okay, integrate this x cube, x power 4 by 4. 6 into 4 gives the value 6, means minus WL x square by 6 into 2, okay, x square by 2, integrating x value, plus w x power 4 by 4. Okay, here already 6l is there, okay, by 4. When you multiply, it gives the value 6 2s 12, 24, 6 4s 24, plus c1. Okay, again integrating. When you integrate this, x square gives the value x cube by 3. X cube by 3 means 12 into 3 gives the value, here 12 into 3 gives the value 36, plus x power 4 gives the value x power 5 by 5. Already you have 24 into 5. 24l into 5 is equals to 120l plus c1x plus c2. You will get the values like this. So at x equals to 0, y is equals to 0, and c2, in the place of c2 you have to put 0. At x is equals to l, y is equals to 0, gives the value 0 minus wlx power 4 by 36 plus w x power 4 by 120 into x. Okay, this is 5, this is cube, okay, plus c1 into l plus minus 7 w l power 4 by 36 plus c1 l. Okay, now sorry, this is the value of 1. c1 7 by 360 wi cube, so this is the value of 7 by 360 wi cube. Okay, means this l gets cancelled out, so this is, sorry, this is 4, this l gets cancelled out, this is I cube. ELY is equals to minus WLX cube by 36 plus WX power 5 by 120 plus 7 by 360 WI cube into X. At X equals to L by 2, ELY is equals to minus WT power 4 by 288 plus WT power 4 3840 plus 7 by 724 L power 4. When you calculate this, gives the value 5 by 768 W L power 4. Y value is 5 by 768 W L power 6 L power 4 by EI. Okay, you will get the values like this. Now this is the new concept here, application of electric circuit. Basic relationship, I is equals to dq by dt is, or u is equals to integration of I dt. This is Ohm's law. Gives the value Ohm's law. Voltage drop across resistance gives the value I. Ri, voltage drop across inductance L is equals to L into di by dt. Voltage drop across capacitance C is equals to Q by C. Okay, where I is the current and Q is the quantity of electricity. Here I is the current and Q is the quantity of electricity. Kirchhoff's law. The algebraic sum of the voltage drop across any closed circuit is equals to the resultant electromotive force in the circuit. The algebraic sum of okay, current flow into any node is 0. Application. This is sum of, okay, space has been not placed. Applications. RL series circuit. Consider a circuit consisting of a resistance R and inductance L in the series with a voltage source E. Okay, this is RL and this is the value of C here. Let I be the current flowing in the circuit at any time t. By Kirchhoff's first law, we can get integrating factor is e power integration R by L into dt is equals to e power R by L into t. So what is the solution here? I is equals to e by R plus C into e power minus R by L into t. Okay. Directly I have find the integrating factor and the solution. LC circuit. Okay. Let I be the current flowing and Q be the change at a time t. The voltage drop across L is equals to L into d I by dt is equals to L into d square Q by dt square. The voltage drop across C is equals to Q by C. By Kirchhoff's first law, we get t square Q by dt square plus Q by LC is equals to 0. T square Q by dt square plus mu square into Q is equals to 0, where I 1 by LC is equals to mu square. This equation represents the electrical oscillation of the current having period 2 pi by mu is equals to 2 pi root LC. Okay, we got the value 2 pi by mu is equals to 2 pi root LC. LCR circuits. This is the LCR circuit. Consider a circuit of condenser C. C is the condenser and inductance L and the resistance R in series. Okay. The voltage drop across L. Across L, what is the voltage drop? L into d square Q by dt square. Voltage drop across C is Q by C. Voltage drop across R is dQ by dt. Okay, by Kirchhoff's law, we get L into d square Q by dt square plus R dQ by dt plus Q by C is equals to 0. D square Q by dt square plus R by L dQ by dt plus Q by CL is equals to 0. D square Q by dt square plus 2 lambda dQ by dt. In the place of R by L, I am putting 2 lambda plus mu square Q is equals to 0. So in the place of R by L, putting 2 lambda value, 1 by LC value, you have to put mu square. I'm taking the value mu square. So when you find the auxiliary equation, m square plus 2 lambda m plus mu square into q is equals to 0, where the value of m is minus lambda c plus or minus lambda square minus u square. Okay, now in the place of LC circuit, EMF PI. Here LC, EM and PI, and here you will have the diagram is here P cos NT circuit. Okay, P cos NT circuit you will have. This equation gives the solution as Q is equals to C1 cos mu t plus C2 sin mu t plus P by mu square minus n square cos NT. Q is equals to C1 cos mu t plus C2 sin mu t plus PT by 2 mu sin mu t. Okay, LCR circuit with EMF P. This is LCR circuit with EMF P cos NT. Here also what you will have like this. Okay, LCR circuit. Solution Q is equals to e power minus lambda C1 root of lambda square minus mu square into t plus C2 e power minus lambda square minus mu square into t plus this value. This is the general solution of this equation. CF represents the free oscillation of the circuit, and free oscillation die out at t increases. Die out as t increases. Pi represents the force oscillation with the persist giving already motion. Okay, example problem. In an LCR circuit, the change Q on the plate of the condenser is given by L into d square Q by dt square plus R dQ by dt plus Q by C is equals to E sin PT. The circuit is turned to resonance, so the P square value is equals to 1 by LC. If the initially the current I and the change Q be 0, show that for small value of R by L, the current in the circuit at time t is given by EI by 2L sin PT. Given differential equation is L into d square double differential d square Q by dt square plus R into dQ by dt plus Q by C is equals to E sin PT. Okay, now divide both sides by L gives the value d square Q by dt square plus R by L dQ by dt plus Q by LC is equals to E by L sin PT. Okay, find the auxiliary equation. So m square plus R by L into m plus 1 by CL is equals to 0. M is equals to minus R by 2L plus of minus R square by 4L square minus 1 by LC. For the value of R by L, minus R by 2L plus or minus I 1 by root LC, that equals to minus R by 2L plus or minus IP, where P square is equals to 1 by LC. CF value is e power minus R by 2L into T C1 plus cos PT plus C2 sin PT. Now 1 minus R by 2L into T C1 cos PT plus C2 sin PT. Okay, neglecting the higher power of R by L. Pi value, for finding the Pi value, 1 by LD square plus RD plus 1 by C into E sin PT. E is equals to 1 by minus LP square plus RD plus 1 by C sin PT. P square is equals to 1 by LC. So E by R integrating sin PT gives the value cos PT. The complete solution of 1 is given by 1 minus r by 2l into t c1 cos pt plus c2 sin pt minus e by rp cos pt. Okay, this is the complete solution we have. So what is the value of I? dq is equals to 1 minus r by 2l into t minus c1 integrate this value. Cos pt gives the value minus sin pt, sin pt gives the value cos pt into p plus r by 2l c1 cos pt plus c2 sin pt plus e by r sin pt. Okay, sorry, this is differentiation. I said integration, that's sorry, this is differentiate. Okay, equation 2 gives c1 is equals to e by rp, that equals to e by 2lp square. Equation 3 gives c2 r c1 by 2lp. Okay, we get I is equals to et by 2l sin pt. Okay, thank you for watching.